Hi everyone, welcome. Today we'll talk about passive house design guidelines. Passive house design is about creating comfortable, healthy, and energy-efficient buildings by controlling moisture, heat, air, and sunlight. It uses a set of guided principles for both new builds and retrofits, ensuring durability and performance. The core principles of passive house. They are built around 10 guided principles. The first 5 are the classic 5: continuous insulation, no thermal bridges, airtightness, high-performance windows and doors, and fresh air with heat recovery. Then we add shading, orientation, daylighting, moisture management, and efficient water heating. Let's learn about continuous insulation. It's like putting a warm coat on your building. It wraps the entire structure so there are no gaps. In winter, it keeps the heat in. In summer, it blocks the heat out. It also keeps wall surfaces warm, so there's no condensation or hidden mold. Next design principle is no thermal bridge. It is any part of a building assembly that allows heat or cool to bypass the insulation layer. Common examples are a concrete slab extending outdoors, poorly insulated window frames, or steel beams cutting through exterior walls. Thermal bridges raise the risk of condensation inside walls or structural layers. This moisture can lead to rot, corrosion, or mold growth, threatening durability and occupant health. Solution is thermal bridge-free design for your home. Introduce thermal breaks, insulative layers, spacers, or separation gaps in structural assemblies. Proper detailing at junctions, walls, floors, roofs, windows ensures the continuity of the thermal barrier. Let's talk about airtight construction. The airtight layer in a passive house acts like a windbreaker, preventing uncontrolled air infiltration. How airtightness is achieved: sheet membranes, fluid-applied membranes, airtight tapes, and sealants. All components must transition seamlessly to maintain an unbroken barrier. Airtightness in a home is confirmed with a blower door test, a critical quality measure. 4. High-performance windows and doors. Every window or door opening is essentially a breach through the insulated, airtight wall assembly. The performance of the window, door unit and its integration into the wall is vital to preserving the building envelope's integrity. So, we will use windows, which has thermally broken insulated frames, warm edge spacers, triple glazing, and low emissivity coatings. They prevent condensation, block drafts, optimize solar gains, and support the overall air barrier. Passive house design calibrates glazing performance for orientation, climate, and building type, which is capturing solar gains in colder months for free heating and blocking unwanted gains in warmer seasons with shading strategies, coatings, and placement. Fifth core principle is fresh air with heat recovery. Balanced ventilation systems, HRVs and ERVs, deliver constant fresh, filtered air while recovering up to 90% of heat from exhaust air. They maintain indoor air quality even in polluted environments. Supporting principles. 6. Shading. Solar gain is valuable in passive house design, but uncontrolled sunlight can cause overheating in warmer seasons. Shading ensures the building captures solar heat when it's needed, in winter, and blocks it when it's not, in summer. Types of shading strategies. Natural shading. Deciduous trees, bare in winter to allow sunlight, leafy in summer to provide shade. Architectural shading. Overhangs, louvers, pergolas, or balconies that block high summer sun while allowing low-angle winter sun. Operable shading. Exterior-mounted shades, blinds, or screens, which are more effective than interior ones since they stop solar radiation before it enters the building. 7. Orientation and form. Orientation and form are first-level design decisions that strongly influence a building's ability to meet passive house performance targets. Orientation. Position the building's main axis to optimize solar gains for the specific climate and building type. In cold climates, maximize winter sun exposure. In hot climates, minimize direct summer sun while still allowing daylight. Form. Simpler forms, rectangular or compact, have less surface area per volume, reducing heat loss and minimizing thermal bridges. Complex shapes with multiple corners, projections, and zigzags require extra insulation and detailing to counteract losses. A simple form also makes it easier to design and execute a continuous airtight barrier. Fewer junctions mean fewer opportunities for leaks, improving airtightness and durability. 8. Daylighting plus solar gain. Strategic windows and layouts harness natural light and passive solar heat, reducing the need for artificial lighting and additional heating. 9. Moisture management. Long-term building performance depends on controlling how heat and moisture move through assemblies. Moisture management strategies are tailored to the specific climate zone: cold, dry, hot, humid, or mixed conditions. Moisture protection goals. Prevent bulk water intrusion, for example, rain, snow, groundwater. Avoid condensation within assemblies where it can cause mold, rot, or corrosion. Key components involved in moisture management. Weather resistive barrier, WRB, which stops rain and external moisture. Air barrier prevents moist air from leaking into assemblies. Vapor control layers regulate diffusion of water vapor. Structure and openings, framing, sheathing, and windows must be detailed for drainage and drying. Climate-specific design for moisture control. Cold climates prevent condensation on interior surfaces. Hot, humid climates stop humid outdoor air from penetrating cooler interior assemblies. Mixed climates balance drying potential in both directions. Analytical tools and methods. Passive house practitioners use thermal and hygrothermal modeling tools like WUFI, Therm, and Flixo. These simulations confirm assemblies are safe, durable, and optimized for the local climate. 10. Efficient water heating plus distribution. Since heating demand is minimized, hot water becomes a key energy load. Efficient heaters, insulated short-run piping, and smart recirculation keep energy and water use low. By combining these 10 principles, passive house design delivers buildings that are durable, low energy, and exceptionally comfortable places where people can truly thrive. Thank you for learning with me. By applying these principles, we're building not just for today, but for our future.